Today, we're going to start the unit circle. Unit circle is one of the most important topics of second semester because it forms the basis for just about everything else we're going to do. All right? So what we see in this object before, we have the coordinate plane with the circle all around it. But it's called the unit circle because the coordinate plane is exactly 1 unit away on the intersection of the circle from the center of the coordinate plane and the circle. Okay. Now, in the unit circle, we're looking at all these different points. The points are going to be the important piece. All right. The point on the coordinate plane is has coordinates of x, comma, y. So we have a horizontal distance, which is x. We have a vertical distance, which is y. Okay. This started to look like the triangle problems that we're doing in the last topic with the terminal point. Okay. Then we have the hypotenuse. Right. Now, we're also looking for reference angles. The reference angle is always going to be, just like we did in the last topic, as close to the origin as possible. So we're going to put our theta there. And our hypotenuse, because it goes from the center of the coordinate plane to the outside of the circle, is a radius. And since the unit circle has a distance of 1 from the center to the outsides, radius is also going to be 1. Okay. This is going to help us organize our information to help us understand the pieces of the unit circle. Okay. So, given the circle, you're going to find the following. Sine. Okay. So the sine of theta, based on right triangle trig, is the opposite over the hypotenuse. Well, the opposite side is y. The hypotenuse is 1. So y over 1 is just y. For cosine, the cosine is the adjacent over hypotenuse. The adjacent side is x. Hypotenuse is 1. So x over 1 is just x. For the tangent of theta, is opposite over adjacent. The opposite is y. The adjacent is x. So tangent is y over x. Okay. Now, one thing about tangent, though, is, and we're going to use this later on in a topic after the unit circle, which is trig identities, is that if x and y are also equal to sine and cosine, then tangent is also equal to sine over cosine. This is going to be an important trig identity that you're going to use later on in this unit. Okay. So remember, very important, that x is equal to cosine and y is equal to sine. Right? So the x part of a point is the cosine, the y part of the point is the sine. So the cosine is the x part of the point, the y is the sine part of the point, the x is cosine, the sine is y, the cosine is x, the sine is y. All right. Another trig identity that we're going to use, like we did with tangent equals sine over cosine, is the Pythagorean theorem identity. Okay, so if we look at our triangle, Pythagorean theorem says that x squared plus y squared equals 1 squared. Well, 1 squared is just 1. Okay, so we don't need to square the 1 because it's just 1. But, based on the information we just were looking at, we can replace the y's and x's. Y would be sine, and x would be cosine. So we have a new trig identity. Sine squared of theta plus cosine squared of theta is going to equal 1. This is another important trig identity that you're going to have to remember. Okay, and use in the next topic after the unit circle. But this is where we get it from, so we wanted to put it in here. All right, now let's go on to the parts of the unit circle that are going to be really important in terms of the radians that we're going to be using to graph our trig functions and then use in our equations later on in the semester. Okay, if you think about the unit circle, we're looking at main angles, 30, 60, 45, 90, all those. The same ones that we had in 45, 45, 90 triangles, and then 30, 60, 90 triangles. Okay, so let's say we have an angle that goes to 120 degrees. So we have our initial, goes to terminal to 120. The issue that we have, though, is if we think of our charts from the 30, 60, 90 and the 45, 45, 90 triangles, where we had sine, cosine, and tangent of those specific angles, nowhere in that chart do we know the sine of 120 or the cosine of 120. So that's information we don't know. So what we have to do is we need to represent all the angles in the unit circle in terms of either 30, 45, or 60 degrees. Okay, we can do this by manipulating how we're looking at each angle. Okay, we can do this by changing where our initial part is. So if we start over there by 180 and go up backwards, that would be 60 degrees. Okay, so now we can identify this terminal side at 120 in terms of 60 degrees. All right, we can represent every angle in the unit circle in some way, shape, or form in this fashion by manipulating how we start and where we end and how many degrees it is. Okay. For example, we can have 330 degrees from the initial to the terminal going counterclockwise, or we can go 30 degrees if we go clockwise. Okay, so what we're going to do is find all these values based on the 30, 60, or 45 degree angles. Okay, if you think back to, I guess it was last week when we're doing, last week, it's probably a couple weeks ago, we're doing the 30, 60, 90 triangles. Okay, we have our x value, we have our y value, which makes up our point x comma y, for 60 degrees. Okay, and our 1 is going to be the distance from the center to the outside edge of the circle, which is our radius. And since it's the unit circle, all the radii are equal to 1. Okay, so if we know x is cosine and y is sine, and we put 60 degrees in for theta, for cosine, and for sine, then if you think about the cosine of 60, based off the chart when we did the 30, 60, 90 triangles, the cosine of 60 was 1/2. Right? When we think back to the 30, 60, 90 triangle chart, we did the sine of 60. The sine of 60 is root 3 over 2. So what we're going to do is we're going to put those values in for x and y at that point. Okay? Now, the other thing about these is the signs of this. If you think about the values and where they are in the coordinate plane, this is in the second quadrant. Okay? All the x values in the second quadrant are negative. All the y values are positive. So we're going to have negative 1/2 for the x value of this particular point. All right? So that point is going to be negative 1/2 comma root 3 over 2. That's the point for 120 degrees. Okay? We can do the same thing with 330, but we're going to put 30 in for our angle. Okay, so if we have x and y again, so we have x of 30 is cosine, x is cosine, y is going to be sine. Replace the thetas with 30s. So if you think about the 30, 60, 90 triangle, when we did those triangles, we had that chart. So the cosine of 30 is root 3 over 2, and the sine of 30 is 1/2. Now, if you think about the signs again, the positive and negatives, this is the fourth quadrant. In the fourth quadrant, the x values are all positive, but the y values, since they're going down, are all negative. So your point for this particular point at 330 degrees is going to be, root 3 over 2, comma, negative 1/2. All right, that's it. There is no practice for this, just the notes for today. We're going to continue with the unit circle on Monday. Have fun over the weekend, and if you're taking the test, take the test.